Good day, grade 12s. I trust you are still doing fantastic. Please note we are still doing the topic of patterns, sequences, and series. And our subtopic for today will be on geometric sequences. And our next lesson will be on the sum of arithmetic series. Just a quick recap from the previous lesson. Patterns are a sequence of numbers that are ordered based on a particular rule, and sequences, they deal with the terms which make a sequence. And lastly, series, they deal with the sum of terms in a particular sequence. Please note, series will cover in the next lesson. So, what is a geometric sequence? It is a sequence of numbers with a common ratio between the consecutive terms. Please, for the consecutive term keyword, please watch our previous lesson. And common ratio, it is the constant amount by which consecutive terms are multiplied. And in general, we define geometric sequence as follows: a, and then a multiplied by r, and then a multiplied by r squared, and so forth. A is the value of the first term, similar to what we have with arithmetic sequences. And then r is the common ratio between the terms and is given by r equals to term 2 over term 1 equals to term 3 over term 2, and so forth. And Tn is the value of the term in position n. So Tn equals to a multiplied by r to the power of n minus 1. And T1 equals to a, and if n equals to 2, we have a multiplied by r, and so forth. So let's consider this simple geometric sequence: 5, 10, 20, 40, and 80. And let's answer these two questions. What is the common ratio? And we must also find the general term for the given geometric sequence. So term 1 equals to 5, term 2 equals to 10, and term 4 equals to 80. To calculate the common ratio, we have R1 equals to term 2 over term 1, which is 10, divided by 5 equals to 2. And then for R2 will be given by 20 over 10, which is 2. And if we continue, we can see that our common ratio equals to 2, because R1 equals to R2 equals to R3. And we know that a, which is our first term, is 5, and r equals to 2, which is our common ratio. And our general formula is given by a multiplied by r to the power of n minus 1. So the general formula is given by Tn equals to 5 multiplied by 2 to the power of n minus 1. If n equals to 1, substituting in our general formula, we get 5. If it's equals to 2, we get 10. 3, we get 20. And for the last one, we'll get 80. So for the general formula, it equals to a multiplied by r to the power of n minus 1. Now, pause your video for a few minutes and answer the simple questions. Please note the order of questioning increases the cognitive level as you move down the questions. Solution for number 1 and 2 is as per below. For number 3 is given by this slide. And for the last one, question number 4, this is the solution. And for more examples, please visit the school website and try to work more on previous year's question papers. And for your homework, please log into the school portal and check under homeworks and assignment. Answer all questions and no late submissions will be accepted. Our next lesson will be on the sum of arithmetic series. Thank you and goodbye.